Going to analyze. This is the moment that with the acknowledge that you have with the materials and the current analysis. This is the most important part, the previous chapter, how to analyze if you have leaks. It's clear now how to analyze the leaks. When you check if you have leaks, checking the resistance of the system. How much is the ohms allowed? How much are the ohms allowed in the system? 1.2 ohms. And if you check for amps, how much are the maximum amount of amps flowing through the 0.001 milliamp? 0.001 amps or 1 milliamp. And that's it. This is the procedure. And I explained different ways to do that yesterday. Moving the fuses, checking the breakers, or using the sure test. You remember that magic element to verify if you have leaks. I recommend try to buy a sure test. You need a sure test. You recover the money easily.
You test every pedestal that a boat is connected to?
Yeah. Doesn't matter if it's European or American.
Okay.
That's good. I love it because it's the only way to verify if you have leaks. One important thing, my friend, that I explained some classes ago. Suppose that the system, when you check the pedestal, you don't have reverse polarity. And if you check the panels, in the AC panel, you don't have the indicator of reverse polarity on. The boat is good. However, when the people connect those detectors of reverse polarity, the yellow ones, you remember those small elements that you connect in the outlet? The inspector find in 2 or 3 outlets of the saloon reverse polarity. And the inspector write in the report that your boat is not good because your boat have reverse polarity. This is true?
Just in a couple outlets? No, just the outlets.
It's just those 3 outlets. The wire is
Switched.
but the boat is not with reverse polarity. You have reverse polarity when you have the LED in the panel on. No? Oh, I have 3 outlets in the saloon. I can fix it. Let me open the, oh yeah, they flip. Which one? Hot and neutral. Hot and neutral in those. Okay, yeah, finito. I solved it. My boat is good.
I was gonna ask, do you ever use those electrical plugs that have the 4 lights on them, just to check the outlets real quick instead of using the sure test?
Correct. Those are excellent.
We use those when I was an electrician. We use those.
Correct. Those are
Also at a Home Depot.
ELCI, something, ELCI.
All it has is 4 lights, and it says like hot, neutral, and then it has a 3rd one if it's reverse polarity.
Correct. Those are excellent. You need verify if in the box if the brackets, the housing of those outlets is marine grade material. That's the only that you need. But this is great because you have the indicator over there.
Yeah, okay.
That's nice.
Really fast.
That's nice. The same with some short power. The socket in the short power cable. There are new ones with those lights indicator for reverse polarity to avoid that the people make mistakes in the connection of the cables. This is nice. Okay, this is important. Very, very important. Okay, we are going to analyze the different type of corrosion in the boat. This is the chapter 7. Chapter 7. Okay, guys. But before of that, let me check quickly the salt water because we talked some chapters ago that salt water is a good conductor of electricity in comparison with fresh water. But we are going to analyze why. This is the composition of salt water. Those are the main components of salt water. And look at this. 55% of the total amount of salt water is chlorine. Oh, wow, chlorine. Chlorine is highly corrosive, no? It's in the corner, right side of the corner of the periodic table with high level of energy. 55%, half of the total amount is chlorine. Wow, that's not good. And the other 30% is sodium. Sodium is other metal, alkali metal. Look at the amount of metal. Look, magnesium, calcium, strontium, potassium, sodium. All of those are metals. Wow. Additionally, sulfur oxide. Additionally, carbonic acid in the salt water. And fluorine. Can you drink salt water?
That's why
You can, but
You'll get the runs.
that's why it says it kills you in the sea if you drink seawater. It dehydrates you because all the sodium.
no, of course,
Sucks all the moisture
of
out of
course.
your body.
And some people is allergic to salt water because it's a lot of bad components for your body. No, this is not good for your body. This is no.
There's a lot of components you use every day. It's not good for your body. Deodorant has aluminum in it. So does the sunscreen
Yeah.
has aluminum. Some people can't wear deodorant because they put too much aluminum in their body and it causes effect.
Still use.
Do you?
Yeah, if I put deodorant on, it like cuts my skin, and so I have like open wounds in my armpit.
Oh wow.
Basically,
Okay.
it rubs the skin off.
Now you understand why salt water is a good electrolyte. It's a good conductor of electricity. Now you understand what happened when your boat is sank and the salt water covers the batteries. Can you recover those batteries? No, because those batteries, the positive terminal and the negative terminal, is like if a piece of rod, metallic rod, you connect negative and positive and discharge and destroy the battery. That's the salt water. It's a perfect conductor of electricity. It's a perfect conductor. It's a good conductor. No? Because those, a lot of metals. It's metallic, practically. No? It's a metallic piece of element. And look at this, my friends. The majority of the chlorine and the majority of the fluorine is mixed, creating molecules. But in the solution of water, 20% of the ions of chlorine are free. What is the meaning of that? Those ions are not stable. They need. For that reason, they attack, they corrode. 20% of the total amount of chlorine, 55%, 20% is free. You know? 20% is free. It's a lot. Those free ions, what is the function? Attack. To be stable. What attack? The copper rudder, the copper propeller, the shaft, yeah, metals. Attack everything. That's chlorine. This is the salt water, my friend. This is good that you understand that salt water is a highly corrosive electrolyte. And my boat is suspended in salt water all the time. Oh, wow. All right? I need protection. Okay, look at this. Don't forget that seawater contains minerals, metals, non-metals. Those components accelerate the corrosion process because they produce stable molecules easily. Look at the amount of elements free. Nitrogen, oxygen, argon. Yeah? It's a lot. And this is the concentration in parts per million and the concentration in value. Thank you. Yeah? Okay. All right. The most common types of corrosion. The most common types. The first one, Danny.
Erosion, corrosion,
Is-
impeding damage.
In pigment damage. The second one.
Crevice corrosion, stagnant solution.
Crevice corrosion is related with stagnant water.
Just like, and I'm going to give a good example. That crevice corrosion you're going to see a lot. People like outboards or any component bolting, you don't put silicone, water gets inside there, it stays stagnant in there, and then you'll pull a bolt out and the bolt looks thick on the outside and then all of a sudden the bolt's thin in the middle. That's crevice corrosion. Pollutus corrosion, dirt and debris accumulating.
Is
Where would you see pollutus corrosion the most? Most common?
Fuel tank.
Fuel tank.
correct, in the fuel tank. In what part of the fuel tank, Porter? On top is one area. Other area that the people make that mistake, especially in all boats. In the bottom they put carpet, and over the carpet the tank.
Should be rubber.
That's catastrophic. The carpet absorbs moisture, and
What'd you do there?
that's not
Also
good.
foam.
Or foam.
Foam is really, I don't put foam back in the boat channel.
No, finito.
I'd rather put wedges in there, because what happens is the foam encapsulated is great, it doesn't move, but then moisture sits between the foam on that. Sometimes I pull out a tank and I take the foam out, and a chunk of the tank comes with the foam.
Yeah, yeah, yeah.
Now, you can foam it. I did it on my boat, but I undercoated the whole tank. So the whole tank is rubberized, and then I foam it.
Okay. This is a good temporary solution for a couple of years.
Yeah, no, for
No for
at
long.
least until I'm gonna get another boat.
Yeah, correct. My friend, remember in the system certification, the fuel tanks should be suspended, separated from the surface. How much distance? The grommets should be quarter inch. You remember, quarter inch, to allow that the humidity, the water flow in the bottom.
Yeah, and make spaces in between it, because the tank, if you're going long spaces, you make a little strip here, a little strip there, so that way the water runs.
They make mats for that, don't they? They make mats where you could just put mats underneath and the water has that.
Little strips.
The
Like
strip,
Yeah.
yeah. This is Baltic corrosion. Pitting corrosion then.
pitting corrosion, localized form of corrosion by which cavities or holes. Where would you see that at? Pitting corrosion. Where would you see that? Well,
Yeah, of course.
What about the magnesium zincs?
Rivets.
Or the,
Yeah, rivets. Correct.
rivets?
Correct. In general, pitting corrosion, in my opinion, is the consequence of crevice corrosion or portis corrosion. When you have stagnant water accumulated long period of time, when you try to dry that area, it's like a perforated, the metal. You make a little pressure over there, and you pass the metal. This is pitting corrosion.
Galvanic corrosion is an electrochemical process in which one metal corrodes preferentially to the other.
To another. Today we are going to check in detail that galvanic corrosion. Intergranular corrosion.
Intergranular corrosion, corrosion in the neighbor of all welding areas.
In the neighbor of the welding area, especially when the people weld marine brackets, support, and the welder is not a professional welder, and it's not a marine grade rod, no. For that reason, it's important. I am going to fabricate some brackets for my boat, for the air conditioning equipment, for the windlass or whatever. I have a friend of mine, good welder, industrial welder. No, my friend. Visit a special shop dedicated to marine welding. The marine welders are special welders, special with a special knowledge in materials. No, this is. Be careful with that. Okay, galvanic corrosion then.
Galvanic corrosion, also called bimetallic corrosion, is a common mode of corrosion failure that occurs when two dissimilar metals are together in a marine environment. The more noble metal, more electronegativity is taxed. The less noble metal, the less negative electronegativity. The less noble metal donates the electrons on the outer orbit, producing erosion to its surface. Galvanic corrosion is considered a local form of corrosion. It is limited to the contact zone in between both metals. The intensity of the process decreases rapidly with increasing distance, even by a few centimeters from the point of contact between both metals. This decreases is greater when the electrolyte is a poor conductor.
Yeah, of course. If the electrolyte is salt water, turn off the cell phone. If the electrolyte is salt water, it increases the phenomenon of corrosion. Later in this chapter, we are going to talk with more details about galvanic corrosion.
Galvanic corrosion. This type of corrosion is localized because of electrical reasons. The small arc of electricity is produced in the contact area between both metals. The intensity of the electrical arc depends on the potential difference, electronegativity, between both metals. Since galvanic corrosion often tends to develop at depth, it is not uncommon that galvanic corrosion perforates parts several millimeters thick. In other words, the intensity of the galvanic corrosion depends on the potential difference between the metals and the compound.
Yeah, don't forget, I emphasize and I talk a lot for that reason in my books. In all the books, I start with that slide about the electronegativities, you remember, and the value of the electronegativity, because this is the fundamental of this program. Select the proper metals. That metal could be together with this. Let me check in the periodic table. Oh, this one, the energy is too high in comparison with this. This one will attack this one. 100% sure. Now we are going to play with the electronegativity tables, and we are going to check what happens if I have iron with zinc. Zinc is a good protector. Let me check if I have zinc with aluminum. What happens if I have zinc with copper? In what scenario zinc is good protector? In what scenario zinc no protect nothing? And now we are going to check.
After checking the electronegativities table on page 9, we can extract
Copper.
with 1.9 is lower than the aluminum 1.5, then the aluminum piece will be eroded. In the case, the aluminum piece is the anode and the copper is the cathode.
Okay, this is the perfect example of the aluminum fuel tank with copper fittings. In the majority of the boats, all boats, you found that copper fittings with aluminum tank. This is not good. This is a worse scenario. What element will be eroded? The aluminum tank or the copper fitting? The aluminum. Because the electronegativity of aluminum is 1.5. Electricity of copper. Okay. Which one will be the anode? The aluminum, the sacrificial anode, the less noble, donate electron. And which one will be the cathode?
Copper.
The copper. The copper at the end of the years will be in perfect condition. And the aluminum around that fitting will be eroded, completely eroded.
So this is the case why are a lot of tanks fitted with copper fittings?
They're not copper fittings. It's a different material. It's not like you go to a boat owner's warehouse. It's not copper. I think they use I don't know what the metal is.
For what?
Like the fittings they sell, that looks like copper.
Oh, but
It's
it's a noble bronze.
It's a noble bronze.
It's a noble bronze. It's a special alloy designed to work with the aluminum tank. Okay? All right. But now we are going to talk about that. Yes, this is the situation, and the anode, the aluminum, will be eroded. Will be eroded. Oh, especially if you use copper fittings in brass. Those Home Depot copper fittings, it's not marine grade. It's brass. Brass have high content of zinc. That's not good. Brass is the worst scenario. That those fittings in brass is copper with a zinc. That's catastrophic. All right. This is the situation. Other great relation is this. It's the relation in between aluminum and steel. Aluminum and steel. Steel is iron, no? Okay, iron is 1.8. Is more noble than aluminum, 1.5. Then the aluminum will be eroded, while the steel gain electrons and work like the cathode. That's clear? This is another example. And this is the periodic table with the electronegativity. We are going to use that one. This is another great example. This is the example in between iron and zinc. Pay attention. Iron is 1.8 and zinc is 1.6. Can I protect a piece of iron with a zinc anode? Yes, because the zinc is less noble and will be attacked for the oxygen and protect the iron. But if I put together iron with zinc, the iron will attack the zinc. The zinc will be eroded, and the iron will be in perfect condition. That's okay? Both scenarios. A similar situation occurred between copper 1.9 and zinc 1.6. Zinc is less noble, and copper attack the zinc. Okay, great. And in the galvanic cell in between zinc and aluminum, pay attention to this. zinc is 1.6 and aluminum is 1.5. Pay attention. Zinc is 1.6 and aluminum 1.5. Can I protect my aluminum hull with a zinc anode? No. It's doing nothing. It's doing nothing. It's evident that zinc is not a good protector for aluminum. In that case, other sacrificial anodes will be better. For example, magnesium, because magnesium is 1.2.
Is the magnesium out of pure magnesium, or is it?
It's an alloy. It's an alloy.
So the zinc, is it just going to be eroded? It's going to be a little bit.
Excuse me?
It's going to be eroded a little bit.
Yeah.
Like, but
Yeah. But protect.
Yeah.
But protect. If that metal protect, will be eroded. For that reason, when you lift your boat once per year, how are the zinc or the sacrificial anodes? Eroded. This is an indication that those sacrificial anodes were working. No? Okay. Okay then. All right. I love this table. Sorry, but you have the table in the book. But I want to try to understand what is the meaning of the galvanic series. This is the galvanic series. Look at this. The elements located on top of the galvanic series will be good sacrificial anodes because the potential energy of those elements is too low. For example, magnesium with 1.2, zinc with 1.6, you remember? Galvanized steel, look, galvanized steel is a good anode. Why? Because it's iron covered with zinc. See, it's iron covered with zinc. Of course, I can use that element to protect until the zinc disappears. After that,
You know what's a good example? A galvanized trailer.
yeah, the trailer.
Compared to a steel trailer. Galvanized while it lasted, but still corrode.
Until the layer of zinc disappears. When the layer of zinc disappears, that trailer is garbage. You know?
Those trailers, man, is all about.
Huh?
So you gotta wash them
Since, since magnesium is so low, why don't they use that for everything?
No, because magnesium, this is a great question. Look, the level of energy of magnesium is too low. He said, why I don't use magnesium for everything? Because magnesium, this is a great question. Because magnesium is here in the second, and those are alkali metals. Depend of the water, magnesium will be good. Magnesium, if it's surrounded for fresh water, is perfect. It's the best. But if magnesium is in salt water, no. If magnesium is in brackish water, no. In fresh water, yes. And this is the analysis here. Look, zinc in fresh water. Zinc in fresh water is poor protection. Zinc in brackish water. Zinc is fair protection in brackish water. Zinc in salt water. Zinc in salt water is recommended. It's good. Let me check aluminum anode. Aluminum anode in fresh water, fair protection. Aluminum anodes in brackish water are recommended. Aluminum anodes in salt water are recommended. Aluminum is good. Okay, let me check magnesium. Magnesium in fresh water are recommended. Magnesium in brackish water, not recommended. Magnesium in salt water, not recommended. You see, this table is nice. Only analyzing the water. Later we are going to check the hull. Okay, this is my friend, the galvanic reference table.
Would it just degrade too quick?
Excuse me?
Like it would degrade too quick? Is that why you wouldn't use magnesium?
It's because the water's too acidic to alkaline.
Yeah, it would just, like, it wouldn't last that long.
Correct. It's an alkaline magnesium. When the magnesium reacts with water, create alkali solutions, no? Because it's an alkali metal. alkali metal. Yeah, according with the level of energy, you suppose that, oh no, I am going to use magnesium for the rest. But no, depend of the water. For that reason, you need analyze according with the water.
But it can work, but it just wouldn't last. So, like,
Yeah, of course.
Yeah, but
Of course.
when it
It's
won't
not
last, it won't last.
yeah, you'll be
Correct.
using it every month.
Correct.
Replacing or whatever.
correct. It's not catastrophic if you.
Yeah.
Yeah. Okay, but the only that I want that you keep clear is that the people always talk about the zinc anodes, and let me tell to you something. For example, in outboards, let me check something about outboards with zinc anodes. Look at this, zinc anodes with outboards. Zinc anodes offer poor protection in outdrives. Poor protection. And for years and years and years, the people say in outboards, Dr. Outboard, replace the zincs, and the people put elements in zinc. No, for outboards, zinc is a poor protection, poor practically nothing. The fastener recommended is a stainless steel fastener and aluminum anodes. Later we are going to talk about that. For outboards, incredible,
It's
no?
cheaper.
Because it's cheaper.
That's why we use it.
Because it's cheaper.
That's really the main reason why they use zinc, not aluminum.
Correct. Yeah, because the aluminum anode. But if you enter in the website of each motor, they have the option, no? The sacrificial anodes in magnesium, in zinc, or in aluminum. In what case I will use magnesium anodes? If the boat will be in a lake in fresh water. That's the unique option. Okay, don't forget this table, the table of galvanic values. No, look at this. The less level of energy metals are magnesium, zinc, and galvanized steel, aluminum also, and those elements will be anodes in this area, and those elements here will be cathodes, absorb electrons, and will be in perfect condition. Look at this: silver, gold, platinum. Of course, the kings. They are not corroded. Yeah, they only accept electrons. The kings only accept money. They never pay.
Guess everything must be in platinum.
Yeah.
That's
Okay.
why platinum is the best producer.
Yeah. Look, platinum is the best. Look, platinum is better than gold. Gold is here, graphite and platinum. Once again, carbon, graphite. I hope you try to refresh. You have, my friend, it's not because it's my book, but this is a wonderful book. You have a lot of information in that book. Okay.
Mr. Lopez, even aluminum boats in salt water, you could only use magnesium.
Right now we are going to talk about that. Aluminum. Aluminum anodes is better for those boats. Okay, galvanic corrosion.
Occurs when two different metals are located together in a corrosive electrolyte group couple forms between the two metals, where one metal becomes the anode and the other becomes the cathode.
Yeah, this is galvanic corrosion. It's clear until this point.
Any water which contains impurities will act as an electrolyte. The risk of galvanic corrosion is reduced by limiting the variety of materials used during boat construction and by ensuring sacrificial anodes are installed. This is particularly important on aluminum boats.
Aluminum and in metallic boats.
The picture below shows the impact of galvanic corrosion caused by cylinder head gaskets due to poor torque and bad grounds. Trouble is when you discover it is way too late and the power head is often wrecked. A poor lapping procedure between the shaft and the propeller can destroy both elements with fatal consequences.
Okay. You remember in the course of diesel that what type of head gasket is recommended for high performance engines? You remember? Copper. It's the unique gasket that can be reused a couple of times, maximum 3 times, no? Copper gasket. But what is the inconvenience? Okay, the price is number one, of course. Other inconvenience is that you have a copper layer with the block is, you remember, cast iron, and the sleeves, the cylinders are in a low-grade carbon steel. You remember? You have low-grade carbon steel, a great cast iron in the block, copper here, and in some cases the head in aluminum. You have 4 dissimilar metals together, and what happens if you torque? If you torque, no good. You have moisture, and this is the consequence.
That's specifically racing motors that you're talking about, right? For the
Yeah.
cast iron block.
Well,
Correct.
even on
Cast iron block.
outboards, some of the new, like the 4-strokes, they have pencil zincs in the head and the exhaust because you have additional metal, the low carbon steel for the sleeve, and you have the aluminum block. If you don't change those zincs, what happens is the inner water passages will get eaten up, and then eventually the gas goes down.
Yeah, this is catastrophic, no? For that reason, this is one reason, Danny, that I don't recommend. For example, when you have, this is talking about the famous Chevy 350, the Chevy 308, the V8 engine, that some people have the block in iron and aluminum heads. In my opinion, I don't recommend that combination because the thermal expansion of those metals is completely different. You remember that in aluminum is twice.
Mercury had a problem with that with those stainless steel risers.
Oh yeah, yeah.
Mercury made stainless steel risers for 4 years. It was like the best thing in the world. But just like you said, the thermal expansion would be different than the cast iron, and it would blow the gasket, and the water would get in the engine lock the engines.
Yeah, be careful with that. I prefer, okay, if I have the block in iron head. If I have aluminum block, aluminum head.
And like these foreign companies, like Yamaha, Honda, they use a lot of dissimilar metals. So you gotta be careful. Suzuki's the worst. Honda's second place, and third is Yamaha.
You say that. Yeah, but that's true. That's true. The similar metal, it's because probably in the engineering department, they don't have people dedicated. They don't have metallurgical engineers. If you want to design perfect boats, not boats, cars, airplanes, you need a lot of metallurgical engineers to analyze the materials. This is the secret. You know what happened in the last rocket in Cape Canaveral? They canceled the launch 3 times.
Right.
3 times because problems with the metals in the fuel lines, in the fuel supply. The similar metals, a lot of leaks, especially at ultra low temperature. And finally, the metallurgical engineers discovered a special alloy for the fittings and the lines to avoid the leaks. At ambient temperature, everything was perfect. When the pressure decreased, the temperature goes down, and they have leaks. All right, great.
According to the ABYC, aluminum fuel tanks never can be installed with copper alloy fittings. Aluminum fittings or stainless steel Series 500 is a good choice.
It's Series 5000. Sorry, it's added one series. It's Series 5000. What is the meaning of that? In aluminum tanks, the aluminum tanks should be marine grade aluminum tanks. Not all the aluminums in the markets are aluminum grade, are marine grade.
He mentioned that yesterday.
Yeah.
Because he used to be one of the main guys that re-welded the Monarch aluminum boats, and their aluminum is not marine
No
grade.
marine grade.
It cracked.
Airplane.
And will be fractured.
Yeah, it cracked.
Will be
That's how
fractured.
he was the only one until he solved the aluminum problem. He was the only guy that would go to the aluminum weld the.
Yeah. Some people. I remember one some years ago in a boat that I replaced the generator, gasoline generator for diesel generators, and we replaced the fuel tanks because originally the fuel tanks
Gas doesn't have a
correct,
return.
and I put a new ones. But the customer said, "I have the tank, Mr. Lopez, aluminum tank," and I said, "Okay, bring the tank," and we installed the tank. And a couple of months later, leaks of fuel in both tanks. And why? Because those tanks were the fuel tanks of a truck, Rastra,
Right.
big one. This is not marine grade aluminum. It's industrial aluminum. And of course, was fractured, was cracked, and leaks of fuel. Should be aluminum grade, Series 5000. The fittings for aluminum tank should be stainless steel, Series 300. You remember which series in particular is the best? 316, 316L, low level of carbon. The 316L is the same that 1810 or 18A. You remember? 1810. Okay. You will be a doctor, he supposes, no? Electrolytic.
Corrosion. Electrolytic corrosion is a process of accelerated corrosion in this process. A metallic surface is continuously corroded by other metals in contact with. Due to the electrolyte and the flow of electrical current between the two metals caused by an external source of current, the movement of electrons facilitates the division of molecules and the creation of new molecules with different atoms from the seed part.
What is the meaning of that? When you have the similar metals, okay, because one metal is more noble than the other one, slow, the more noble will attack the less noble. This is galvanic corrosion. No problem. But that process is too fast? No. Spend years that the more noble metal attack the less noble. Okay. But what happens if both the similar metals together and additionally one cable with electricity is touching that couple?
Advances it.
Oh, accelerate the arc, increase the arc, and the more noble attack the less noble faster and erode the less noble.
Increasing power.
Excuse me?
You're increasing the power on the...
Increasing the current.
Yeah,
the current.
And then if it's in salt water, it's even faster.
Because if additionally you have humidity, salt water in between, blah, 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 is accelerated. And the consequences are catastrophic. For example, my friends, there are a lot of true holes that the metal of the body of the true hole is aqualloy or monel, is a good marine grade copper alloy. However, the washer, the nut lose the same copper, but it's not in marine grade copper. It's industrial copper, because the fabricator of the nuts is other company. When you put the nut, the alloy of the nut is different than the naval alloy of the true hole, and this nut destroyed the body of the true hole. This is a very common problem in some years ago in some transducers. The body of the transducer, great material, but the nut to fix it, the transducer on the hole, no marine grade, and destroyed the body of those transducers. Yeah, drops and water penetrate. That's incredible. Oh, look at this. Sorry, look at this. Hey, my friend, what is this? What is this? The scoop of the true hole. You see? Outside. Oh, it's eroded. Why? Because the true hole is not bonded. Or it's bonded so, and some leaks of current attack, and look at this. Destroyed, this is electrolysis. Destroyed the metal. The metal is eaten. Look at this. Wow, disappeared the metal. Of course you have a leak of water in the boat. Yeah. Let me finish that history about those true holes in different metal than the nut. I remember some years ago I was working in a marina, New River Marine, in a Marina Mile Road. That company disappeared, and today is yacht management in Marina Mile Road, close to Roscioli, in that area. And one day in the morning I received the paper for me. Okay, you need install one generator in that hatteras. Okay, I start with the installation of the generator, and when I try to do the hole for the true hole for the generator, normally the first step is, you remember, make a pilot drill and verify if in that area will be good, the true hole. When I did the pilot drill, I passed the drill, and a small drill bit, water. A lot of water coming out. I remember it was 10 a.m. when I drilled the hole. A lot of water coming out. I enter in the boat. I see the drill, the hole that I did, but that area is dry. Where is coming that amount of water? This area is dry, completely dry. I call other guy, hey man, look, and go outside. Look at this, water coming out. Pay attention. 10 a.m. 11 a.m. and the water continue going out, and the boat internally dry. 12, and the water continue out. 1 p.m. and the water reduce the value but continue going out. 3.5 hours water coming out through that hole. I did other drills in other part. The manager authorized other drills and water coming out. Okay. We discovered what was the problem later. You remember when in the next class we are going to explain that the construction of the hull, you have layer of fiberglass, and foam in between, no? Okay, one of the true hulls, you remember I explained a couple of minutes ago, the material of the true hull, good material, the not good, attack, and the water penetrates over there and impregnate with water the foam in the entire boat. The foam was soaked with water, full of water, all the boat full of water. When I drill in that area, the water goes out through that hole, that hole. Later, we asked to the guy that operated the travel lift, and he said, now I understand why that boat was too heavy, was full of water. The sandwich in between the layers of fiberglass, full of water. We wait 3 days until all of the water was drained. Can you imagine one situation like this, how can destroy the boat? Incredible, no? All the water was saturated the foam. Of course, after that, when the boat was dry, we touched the hull, Danny, and you feel a hollow. I remember the insurance visit the boat, and the boat was declared total.
Yeah, what happens to stagnant water? What does it turn into? Acidic, no?
Yeah.
Then it starts breaking down the material.
Yeah.
That's why the foam gets eaten up. It turns acidic. It takes time. Not something that happens overnight. That's why every time you drill a hole in anything, you should seal it.
Yeah, that's true. And after that, we checked the rest of the boat. Garbage, completely garbage. The water destroyed the boat. This is a great history. Because in the future, you will work in good marinas, and you can see different
Oh, you're gonna see
problems. Different problems.